In this topic, we will learn about the multiplication of matrices. First, let's look at when can two matrices be multiplied. Here we have matrix A and matrix B. We can multiply two matrices if the number of columns in one of the matrix is equals to the number of rows in the other matrix. Let's look at this example here. Matrix A has the order of 2 by 3 and matrix B here has the order of 3 by 1. The number of columns in matrix A is the same as the number of rows in matrix B, and hence we can multiply A with B. Can we multiply matrix C with matrix D? Let's look at the dimension. The dimension of matrix C is 1 by 2 and the dimension of matrix D is 2 by 2. Since the number of columns in matrix C is equals to the number of rows in matrix D, yes, we can multiply CD. What about DC? Looking at the dimension, the number of columns in matrix D is not the same as the number of rows in matrix C, and hence we cannot multiply matrix D with matrix C. Therefore, note that the multiplication of CD is not always equals to the multiplication of DC. Can we multiply EF? The answer is no. What about FE? The answer is no as well. Can we multiply matrix G with matrix H? Yes, the number of columns in matrix G is the same as the number of rows in matrix H. In summary, we can multiply two matrices if the number of columns in one of the matrix is equals to the number of rows in the other matrix. Let's look at what is the order or the dimension of the matrix product. What this means is that, what is the dimension of the matrix after multiplying these two matrices here? The dimension of matrix G is 3 by 2. The dimension of matrix H is 2 by 2. We can multiply these two matrices here, and the order of the matrix product GH will be 3 by 2. What is the order of the matrix product JK? Since the number of columns in matrix J is the same as the number of rows in matrix K, we can multiply matrix J with matrix K. And the order of the matrix product JK will be 1 by 1. What is the order of the matrix product MN? Yes, it will be 2 by 3. And what is the order of the matrix product ST? Yes, it will be 1 by 2. In summary, if two matrices A and B can be multiplied, and matrix A has the order M by N and matrix B has the order N by P, the order of the matrix products AB is simply M by P. We'll simply take the first number and the last number to give us the order of the matrix product. Next, let us look at how to multiply two matrices. We are asked to evaluate this matrix multiplied by this matrix here. First, we have to look at the dimension of the matrices to see whether we can multiply these two matrices. Since the number of columns in this matrix is the same as the number of rows in the other matrix, we can multiply these two matrices to give us the order of the matrix product to be 3 by 2. So the first step is to write down the order of the matrices and the order of the matrix products. Next, since the matrix product is 3 by 2, we can indicate it by putting dots in 3 rows and 2 columns. There should be 3 times 2, which is 6 dots. To find the elements in the first row, first column, we'll multiply the first row in the first matrix with the first column in the other matrix. To do so, we will multiply each element in the corresponding rows and columns. For example, we will multiply 2 by 3, 4 by -1, and -1 by 2. And we will add up all these products here. To find the elements in the first row, second column, we will multiply the first row in the first matrix with the second column in the other matrix. And we'll multiply the elements in the corresponding row and column. And we will add them all up. And hence here we have 2 multiplied by 5 plus 4 multiplied by 0 plus -1 multiplied by -2. To find the elements in the second row, first column, we will multiply the second row with the first column. And this will give us 3 multiplied by 3 plus 5 multiplied by -1 plus 2 multiplied by 2. To find the elements in the second row, second column, we will multiply the second row with the second column. And it will give us this. To find the elements in the third row, first column, we'll multiply the elements in the third row with the corresponding elements in the first column. And we will have this. Finally, to find the elements in the third row, third column, we multiply the corresponding elements in the third row with the third column. And we will have -2 times 5 plus 1 times 0 plus 6 times -2. Simplifying, we will have this matrix here. And we will have evaluated the multiplication of these two matrices here. Now let's look at this example here. We are asked to evaluate A square. Now A square is equals to matrix A multiplied by matrix A. Looking at the order of the matrices, we know that we can multiply these two matrices. And the order of the matrix product will be 2 by 2 as well. So we will draw a bracket and we'll indicate some dots in 2 rows and 2 columns. To find the elements in the first row, first column, we will multiply the first row with the first column. And we will have 2 times 2 plus 1 times -1. To find the elements in the first row, second column, we will multiply the first row with the second column to give us 2 times 1 plus 1 times 3. To find the elements in the second row, first column, we will multiply the second row with the first column to give us this. And finally, to find the elements in the second row, second column, we will multiply the second row with the second column to give us this. Simplifying, we will have A square equals to 3, 5, -5, 8. In summary, when we multiply two matrices, we will first write down the order of the matrix, and we'll write down the order of the matrix product. Next, we will highlight the row in the first matrix and the column in the other matrix to remind us that we will always use the row in the first matrix to multiply by the columns in the other matrix. Then we will multiply and add up accordingly. Finally, we will simplify to give us the answer for the matrix product. And that's all for this topic.